Today is May 15th, and we're going to talk about area of a region between two curves, okay, today. All right, so we want to talk about the shaded region for this first graph right here, okay? And let's call this top curve, okay, y equals f of x, okay? So this is y equals f of x, okay? And then right here, we're going to call the starting point A, and then this would be, I'm going to call that end point B, okay? And then what we're going to create is like a bunch of rectangles, right? Okay. So if you do that, I'm going to make one representative one that's really, really skinny, right? Okay. So this represents a rectangle, okay, that's really, really skinny. The width is really, really small, okay? And this would be, this little width right here would be my dx. That's represented by the dx. And the length or the height of this rectangle would be the function value, f of x. Okay, so to find this area, all I would need to do is collect all the rectangles between A and B, right? And we do that with an integral. So from A to B, f of x, and that would be the length or the height, times dx, and that would give you the area, okay? And that would give you the area of this shaded region right here, okay? All right, so then we want to go to the next one, okay? And this one, this bottom curve right here, okay, let's call this one y equals g of x. We're going to go through kind of the same thing. How do you get the shaded region, right? Well, you'd start this at A and you'd stop this at B, okay? And a representative rectangle would be like this one right here, okay? Its thickness would be dx, okay? And then this would be the height of it, or the length of the rectangle would be g of x, okay? And so this would have an integral from A to B of g of x dx. And that would represent this area, okay? All right, let's go to the next one. So one thing I want you to understand is that if we were to take this area, right, and from this, remove this part, right? So we'd remove this part, so we'd have to subtract. We'd be left with this part, right? And that's what we have here, okay? So well, this right here, the top curve is still y equals f of x. And the bottom curve, I still want to be y equals g of x, right? Okay, but now what we're going to do, we're going to start it right here. That's still my A. And we're going to end it right here. And that's my B. Okay, and we still have a rectangle in here, right? So that would be this one right here. Okay, what's the thickness of it? Well, it would still be dx. This would still be a dx right here, okay? Now, what would this be right here? How long would that be? Well, if I know from here to here is f of x, and from here to here is g of x. So if I took the whole thing and minus this part right here, I would have the length of this rectangle, right? And that's how we're going to do it, okay? So we're going to take the integral from a to b, okay? And I'm going to put a bracket in here, okay? And it's going to be f of x minus g of x. Now we're trying to find areas, so we always want to make this one positive, right? And I need to have the dx, okay? So this would be the length. The f of x minus g of x would be the length, right? This would be f of x minus g of x, right? Instead of just plain old f of x, instead of plain just g of x, it'd be f of x minus g of x, okay? Now, we always want this because we're trying to find areas. So this is straight out area, okay? And we're going to use integrals to find the area between two curves, okay? What we need to do is we need this to be positive, okay? There's other ways you could do this. You could use absolute value to make it positive, but the simplest way, and we want to try to avoid using absolute value, okay? Because it's hard to integrate an absolute value function, okay? So what we want to do is we always want to do the biggest one minus the smallest one. Now, if we're going up and down, that would show up by taking the top minus the bottom. And this is going to be a big idea for the rest of the class, okay, for the rest of the stuff we do. We want to do top minus the bottom. Because if we take the top, the one that's furthest away, right, minus the one closest to the x-axis, okay, so that'd be top minus bottom, okay, that will always give us a positive value, okay? Now, what's coming up is we're going to have to go sideways sometimes, okay? Instead of going up and down, we're going to have to go sideways, okay? And how would you make this distance if we were going sideways? Well, what's bigger, things to the right or things to the left? And it would be things to the right, okay? So the right, like B is bigger than A, right? So if we're going sideways, instead of being top minus bottom, we're going to have to use right minus left, okay? And our thickness, I'm going to say this right now, I'm going to set us up, okay? Our thicknesses wouldn't be dx, they would be dy. And our functions wouldn't be y equals f of x and y equals g of x, they would be actually x equals f of y and x equals g of y. The y would have to be the input, and then we get out an x, okay? All right? Okay, so really it's about integrating from start to stop, right? And top minus bottom, okay? Top minus bottom, okay? Because that will guarantee that we have a positive value when we, on the length of those representative rectangles, okay? All right, let's just go do some problems now. So let's go to example 1. Okay, so for the first example, what we want to do is we want to find the area of the region bounded by the graphs of y equals x squared plus 2. Okay, so that's this one right here, right? Y equals x squared plus 2. So let me add this in. Y equals x squared plus 2. Y equals negative x. That's this line right here, right? So this is y equals negative x. Okay, x equals 0. Okay, x equals 0. And that would be this part right here, this line right here, right? It'd be the x equals 0 is the y-axis, and x equals 1, okay? So that would be right here to right here, okay? And I'm gonna get a colored pencil, and I'm gonna color in the region that we're talking about, okay? So I'm gonna color in this region right here, because this is the region we're talking about. Okay, so when we say bounded, it's like fences, okay? So this is bounded on 4 sides. This is the top, this is the bottom, this is the left, and this is the right, okay? All right, so I wanna find the area of this red region, right? Okay, so how do I do it? Well, I wanna start making rectangles, right? I'm gonna make vertical rectangles, okay? All right, so those rectangles are gonna be found by taking the top curve minus the bottom curve, that would be the length, and then the width would be dx, okay, our thickness, okay? And then we're gonna start this, we wanna start collecting these at 0 and stop it at 1, okay? So that's what we're gonna do is we're gonna write an integral. We're gonna go from 0 to 1, okay? And I'm gonna use a bracket, okay? And the top curve is x squared plus 2. So I'm gonna put that in parentheses. You wouldn't have to, okay? But x squared plus 2, I'm just showing you that's the top, okay? Minus what's the bottom? The bottom is negative x, right? So minus negative x. Okay, and then close the bracket, and that would be the length or the height of our rectangles, okay? And then times the thickness dx, okay? We can clean this up a little bit. This would be the integral from 0 to 1 of x squared plus 2, and this would be plus x, right? So this just becomes x squared plus x plus 2, and then dx, right? Well, we're going to do a lot of these we're going to do with technology, but this is one we can do by hand. So we're going to do it by hand, okay? So that would mean this integral is equal to x cubed over 3 plus x squared over 2 plus 2x, and then we're going to evaluate that, right? From 0 to 1. Okay, so I'm going to come down here. okay? And then this would be 1 cubed over 3 plus 1 squared over 2 plus 2 times 1. I'm going to put a bracket around this. I should put equals right there. And then minus, and this would be 0 cubed over 3 plus 0 squared over 2 plus 2 times 0, right? Okay, what do we know about this one? That's going to be 0, right? So this turns out to be 1/3 plus 1/2 plus 2, right? And a common denominator for all of these would be 6, right? So this would be 2/6 plus 3/6 plus, and then this would be 12/6 because 12/6 is 2, okay? And then if we add those together, we would get 17/6. So that's the area. The area is 17/6, okay? And that's how you do this, okay? Some different scenarios that I'm going to go over with the following examples, okay? But that's really the gist of it, okay? Yeah, that's it. Okay, so let's go to example 2. Okay, so the last example is one where they didn't intersect, and I gave you actually the 4 sides, okay, or the boundaries, right? This is bounded by only 2 curves because the 2 curves are intersecting, okay? So this is about how do you do this? How do you find the region lying between 2 intersecting curves, okay? So the very first thing we've got to do, okay, is I'm going to shade in this region right here, okay? And so that's what we're trying to find. So we're trying to find this shaded region right here, okay? This is my chance to do kindergarten work, right? Color in. Okay, so we're gonna go top minus bottom, right? Okay, so I'm showing this to represent one rectangle, okay? And we would wanna start them right here, and this length would be 0 right here, right? And then we're gonna make them, and we're gonna go all the way across until we reach right here, right? So this is gonna be the start of the integration, and this is gonna be the end, okay? And I know that this top curve right here is y, or f of x is equal to 2 minus x squared. Okay, and this one right here is g of x is equal to x. Okay, now the very first thing we need to do, you can't rely off reading numbers off a graph. Now these, I'm going to tell you, we set them up so that these are nice. Okay, but you have to show this. Okay, so what we have to do is we have to find this intersection point and this intersection point. Okay, and we know that for these 2 curves, they have the same output. Okay, they both have an output that's right here. Okay, all right, so what we can do is set them each equal to each other. Okay, so we have to find the intersection points. Okay, so the way we do that is we're going to set these 2 functions equal to each other. Okay, so x is equal to 2 minus x squared, right? Okay, and so how do you solve this? Well, you're going to move, because it's a quadratic, you're going to move everything to one side. So we have x squared plus the x, and when we move the 2 over, it's going to be minus 2 is equal to 0. Okay, and then we're going to factor this, right? Okay, so 2 numbers that multiply to give you -2 and add to give you 1 would be +2 and -1. So this factors into x plus 2 times x minus 1 equals 0, and that would mean x is equal to -2 and x is equal to 1, which makes sense, right? What we see, that makes sense, okay? So what's the y coordinate, right? So this intersection point right here, okay, right here is -2, sorry, not -2, it's 1, 1, right? Because we could put it into the g of x function, right? If you put in 1, you get out 1, right? So this is the point 1, 1, and this point right here is -2, -2, okay? So that's going to allow us to get the area, okay? So this area is going to equal the integral, and we're going to start creating these at this x value and stop them at this x value. So we're going to start creating them at -2, and we're going to stop at 1. the length of the rectangle or the height of the rectangle would be the top curve, which would be, okay, I'm going to use a bracket here. So 2 minus x squared minus the bottom curve, which is x. Okay, and then dx, because that little thickness is, that width is dx, okay? All right, so this could be cleaned up a little bit. This would be the integral from -2 to 1 of negative x squared minus x plus 2, and then dx. And that's something that's pretty easy to integrate, okay? So we're going to do it by hand again, okay? So this would be equal to, this area would equal negative x cubed over 3 minus x squared over 2 plus 2x, and I'm going to evaluate that from -2 to 1. Okay, so this would be negative 1 cubed over 3 minus 1 squared over 2 plus 2 times 1 minus a negative of -2 cubed over 3 minus -2 squared over 2 plus 2 times -2. I'm going to close my bracket. I'm going to slide it up a little bit. I'm trying to remember to slide things up. Okay, so this is equal to -1/3 minus 1/2 plus 2. I'm gonna put brackets around that, okay? Minus. There's other ways to do this, so I don't want you to think, oh, you have to have the brackets. No, you could do this other ways, okay? I'm just trying to think of how the simplest way to explain this, okay? So when we take this -2 and we cubed it, we're gonna get -8, but we're gonna take the negative of it, right? So that actually makes it become positive. So this one becomes 8/3. There's so many signs in here, I'm waiting to do this. That's why I wrote the bracket, okay? And then -2 squared would be 4. Okay, so minus 4 halves. Okay, and then this becomes -4, right? And I would do that before I distribute this negative, okay? So this is -1/3. And I didn't reduce this one because I have a half over here, okay? And I can combine them then, okay? That's the reason. Minus 1/2 plus 2 minus 8/3. Then this one becomes plus 4 halves and then plus 4. If you did reduce that, it wouldn't be wrong, okay? All right, so we have -8/3 and a -1/3 and a -8/3. That makes -9/3. I have a -1/2 and I have positive 4 halves. So that would make 3 halves. So plus 3 halves, okay? And then I have positive 2 and positive 4, which makes positive 6, okay? All right, so, I mean, this one we could reduce, okay? And let's go ahead and do that, okay? I think that would be easier, okay? Let's reduce this one. So that makes -3 plus this 6 would make 3, right? So now we have 3 halves plus 3, okay? And now all we need to do is get a common denominator of 2, right? So this would be, okay, 3 halves plus 6 halves, because 6 halves is 3, right? And so this makes an area of 9 halves, okay? All right, and that's the area of that shaded region, okay? All right, let's go to example number 3. So this next example deals with, okay, so what if you have two curves that intersect at more than 2 points, okay? So the last one was just 2 points, right? But this one actually intersects at 3 different spots, okay? So we have f of x equals 3x cubed minus x squared minus 10x, and we have g of x is equal to -x squared plus 2x, okay? So this is a parabola, right? So that's this one. It has to be this one, okay? And this S-shaped curve, right? That's the cubic, right? Okay, so this one right here, okay, is g of x. And we know it equals -x squared plus 2x. All right, and then I know this one is f of x. And we're going to use technology to do most of this work, okay? And then 3x cubed minus x squared minus 10x. Okay, All right, and then I'm going to shade in. We want to find this area, okay? And you don't have to have colored pencils. I mean, you could just use your regular pencil, okay? Let me make this a little bit bigger. Okay. All right. So we're trying to find this red region, right? Okay. The very first thing we need to know, okay, and what happens here, in essence, what happens is the top curve changes, okay, and the bottom curve changes. So for this one from here to here, okay, that's the cubic one, right? That's f of x, okay, and the bottom one is g of x. But all of a sudden, once we hit this point right here, right, it changes. Now g of x is the top curve, and f of x is now the bottom curve, right? So to do this, basically what we have to do is we have to create two integrals, okay? Now, I realize you may be thinking, Mr. Mitchell, I can just read the points off the graph. Yes, I realize that, but you can't always do that, all right? So I wanna go through how do you find these intersections, okay? So you always are gonna find the intersections by setting the two functions equal to each other, okay? So, and we're going to use technology to solve this, okay? So this is one thing that is taught for the AP exam, okay? You have to be able to find the intersection, okay? So this is 3x cubed minus x squared minus 10x, and that's equal to negative x squared plus 2x, right? Okay, and to solve this, okay, well, actually, we could actually make this one be y1, okay? So I'm going to do a different color to show you. In our graphing calculator, we're going to let this one be y1, and I'm going to let this one be y2, and we're going to find the intersections, okay? All right. And then what we're going to do is I'm going to show you how to store these, okay? We've done this before. We've stored stuff before, but I want to show you because as soon as you use your calc menu and you find the intersection, okay? And then you have that in your calculator and you go to find this one, okay? As soon as you find this one's lost, okay? So I'm going to show you how to store that on your graphing calculator, okay? So we're going to go to our graphing calculator now. All right, so what you want to do is you want to press y equals, okay? I'm going to clear out any function you have in there. Let's do 3x cubed. Let's do the cubic one. 3x to the third. Make sure you come out of the exponent. And then minus x squared. And then minus 10x. Okay, and then y2 is the negative x squared plus 2x. Okay, and you can use the grid to help us figure out, like, what do we do the window settings at, right? So let's go to window. Okay, so looking at your paper, okay, let's make the x-min negative 3. Let's make the x-max 3. And then let's make the x scale by 1, because that's what our grid does, okay? And then y-min would be, let's make negative 9. And our y-max would be 7. And then our y scale would be, let's go by ones. Okay? And then we can graph this. And it looks like what we have, right? Okay? A little stretch because this isn't a perfect square. Okay? Our window isn't. All right, so we want to find this point right here, right? And then we want to find this point. I think it's 0, 0. Okay? And this point right here, okay? So we're going to go second, calc, and number 5, intersect. Okay? And the first curve, I'm just gonna automatically get close to where, whoops, a little too far. Okay, right there. I'm just gonna get close to that first one. Okay, so enter, and then second curve is the parabola, right? Enter. Guess we're close to the one we want to find, the one on the left. Enter. Okay, so it's x equals negative 2, negative 8. I mean, that's kind of what it looks like on the graph too. Okay. All right, we want to store this. Now, I realize you could type negative 2, okay? And that wouldn't be that bad, right? Okay, but what I want to do is we're going to press second, quit, okay? And we're going to take our x value, okay? Because it automatically stores it, but as soon as you find the next one, it's going to be gone, okay? So we want to store this, and I would do alphabetical order from left to right, okay? So this is x equals 2, so I'm going to call that one my A, okay? So I'm going to store, okay, I'm going to store that answer as alpha A, okay? So now when I type A, because a lot of times these are like, 9-digit decimals, okay? So we want to hold all of them. That's why that's why I'm teaching you to store it, okay? So it's -2, right? A is -2 now. Until you change it, A is going to be -2 in the calculator, okay? All right, let's go to the next one. So let's press graph. And then we're going to find this one, okay? So second, calc, intersect, enter, and just get close to that middle one. Enter. And the intersection is 0, 0, okay? So now we're going to go back, second quit, and we want to store this one as B. So X, we could type it this way. We could do it this way. I showed you that X is stored, okay? But you could do X, store, and then alpha B. And from here on out, B is going to be 0. Okay, so if I just type B, look, it's going to give you 0. Okay, now we need to find the next one, right? So second, calc, and then intersect 5. Okay, and let's just get over to that other one. So enter, enter, enter. Okay, and it's x equals 2. All right, so again, we're going to go second quit, and we're going to take our x, that x, that's 2 now, right? And we're going to store it as alpha C. And from here on out, anytime I use C, it's 2. Okay? All right, so let's go back to our paper, all right? And then let's record these values. So for this, we let x equal, when we solved it, we got x is equal to -2. And then we also got x is equal to 0. And then we also got x is equal to 2, okay? And then we're going to let A equal -2, B equals 0, and C equal 2. Okay, so what we need to do to find the area, okay, that's going to be equal to the integral, okay? And we're going to start this at -2, so I'm going to call that A, to B of, and the top curve would be f of x, I'm going to use a bracket here, f of x minus g of x, close the bracket, dx, okay? And let me slide it just a little bit, okay? That would give me this area right here, okay? This first region right here, okay? Then I need to get this region, right? And to get that region, I'm going to need to add the integral, okay, from b to c of, okay, so the top curve is now g of x, right? So it'd have to be g of x minus f of x. Close the bracket, and then dx, right? Okay. Now, okay, so in our calculator, we stored this f of x as that's my y1, right? And the g of x is my y2. And over here, g of x would be y2 and minus, and then this would be y sub 1, right? So I'm going to put it in with a's and b's and y1s, okay? And let me slide that up. Sorry, guys. Okay, I'm going to put it in my calculator that way, okay? But you need to write it like this, okay? Or, okay, so it's a lot of times when you do these intersections, these are more than just like simple numbers like 2 and -2. So that's why I'm showing you this, okay? I'm showing you with the calculator how to integrate, all right? And how to solve with the graphing calculator, okay? And how to write it up so that somebody else could read this and understand what you're doing. Because a lot of times you don't want to write all 9 decimal places right here, you know? Okay? I just created simple examples that are just easy. They're nice numbers, okay? That in essence, okay? All right, so let's go to our graphing calculator and put this in and get an answer, okay? Okay, so we're gonna go alpha window and then integrate, and then alpha A, because that's -2, and alpha B, because that's 0, okay? And the top curve was y1, right? So alpha trace y1 minus alpha trace to get y2, and then dx. And this just simplifies putting it into your calculator, okay? And then plus, right? Then we'd have to integrate again. So alpha window for from B, so alpha B to alpha C. And they switch, right? So it's going to be Y2. So alpha trace to get the Y menu. So Y2 minus trace Y1. And then DX. And then we'll press enter. And we get 24. Okay, so the area is 24, is exactly 24. Okay, so we'll go back to our paper and we'll record this. Okay, so this area is equal to 24. And that's it. Okay, let's go to example number 4. Okay, guys, this is going to be the hardest one, I think. And I'm hoping that it's like it'll start to make sense to you and all that, okay? Because here's the thing. We want to find, it's still area of the region bounded by these two curves, right? And it's going to be, it's this region right here, okay? So I'm going to shade this in. And we're gonna want to integrate with respect to y. Okay, and I'm going to explain why. And I think that's the hard part. The integration is not going to be hard at all. Okay, and the solving these intersection points, that's not going to be hard either. Okay, but it's understanding this. Okay, so you actually have two options. One is really hard and one is fairly easy. Okay, if we try to do what we've been doing, right? Okay, and we're trying to create these rectangles and we do them vertically, right? All right, where the height of the rectangle is vertical, okay? If we try to do that, we would start them right here at this point, at this x value, right? And we'd start creating them, okay? Like the Etch-a-Sketch thing, right? Remember that's Etch-a-Sketch? And then it'd be this line, right? Because that's the top curve minus this bottom curve, right? And we would do that until right here, right? And it'd be the line minus this square root function down here, right? And then all of a sudden it switches, right? And then we'd have to use two integrals to do this. So this is possible. So I want to say that this is possible. And then we would start integrating this from this point right here, from this intersection point to the furthest right point, which would be right here. And so you'd have to find the vertex of this to know that's right at 3, okay? All right, so that's one way of doing it. And you'd have to use two integrals, one from this point to this point, the line minus this curve, right? And so you would in essence get that area right there, okay? And then you have to add this area. And this would be the top square root function minus the bottom square root function, right? And then you'd stop the integration right here. That would perfectly work. It would work, okay? But you need to know other ways, okay? And a faster way, a better way is if instead of doing vertical rectangles, we did horizontal rectangles, okay? And if we did horizontal rectangles, we would start right here and we would make them and we'd go this way, all right? And it would be this curve right here, all right, minus, okay, well, we'd go here and we'd start making them right here all the way until right here. And we would only need one integral to do it, okay? Now, a lot of times I'm going to tell you, you want to do this when you have things that aren't functions, okay? So the things that we've been integrating so far have been functions, right? This is not a function, right? So for like this, at this point right here, there's two different y values, right? That's not a function, okay? So that's when you want to go and see, hey, could I do this sideways, okay? All right. So the way to do this is first we got to find these intersection points, okay? And then we want to, okay, so what happens is normally we put an X in and we get a Y out. If we want to go sideways, what we want to do is put a Y in and get an X out. So what we want to do is we want to solve the equations for X. Okay, And when do we want to do this? We want to do this when we don't have a function, okay? When we're trying to integrate and one of the curves is not a function, okay? All right, so we're going to start with this one. Well, let's just start with this. Let's start with the easy one, okay? So y equals x minus 1, right? That would mean y plus 1 would equal x. Okay, we're done. We know, well, we're not completely done. We're done with that one, right? We know that this line is y equals x minus 1, but it's also x equals y plus 1, okay? So I'm going to write this one right here. This is x now equal to y plus 1. Okay, now we want to take this one, y equals plus or minus the square root of 3 minus x. Okay, so what I want to do is I want to get rid of the square root, right? So I'm going to have to square both sides. So that's going to take y and I'm going to square it and equals, and I'm going to take the plus or minus and the square root of 3 minus x. And I'm going to square that. Okay, so this left side would be y squared. Okay, equals. Well, what happens when you square a positive or a negative? Either when you square, you're going to get a positive, right? And so the square is going to take care of this and it's going to make it positive, and it's also going to cancel out the square root. So we're going to be left with 3 minus x. Okay, so now I can solve this for x by moving the x over, okay, and moving the y squared over. So 3 minus y squared. Okay, so now see how this is now, it is a function, but it's not, y is not a function of x. X is a function of y, okay? All right, so now this one is, the new equation for this one is x is equal to 3 minus y squared. And this is the situation that I talked about earlier, when if we're going sideways like this, right? To get this length of this rectangle that's laying on its side to be positive, we're going to have to do the right curve minus the left curve, okay? So it's going to be 3 minus y squared minus y plus 1, okay, when we go to integrate, okay? Now, we need to find this. We want to know, when do we start integrating, okay? So we need to find these intersection points, okay? So we can do that because for these intersection points, the x's have to be the same, right? The x's have to be the same. So we're going to set y plus 1 is equal to 3 minus y squared. Okay, so this is a quadratic, so I'm going to move everything to the other side, okay? All right, so if I move this to the left-hand side, I get y squared plus the y. I have 1, but I'm going to need to subtract 3, so that's going to be minus 2 equals 0. And then this becomes y plus 2 times y minus 1, because I'm just factoring, equals 0. That means y would have to equal negative 2 or y equals 1. Okay? Now, when y equals negative 2, okay, when y equals negative 2, I know the x is negative 2 plus 1, so that'd be negative 1, right? So this point right here is negative 1 comma negative 2. And I realize you could just read that off the graph, but I don't want you to, okay? You got to know how to do this, okay? And then this point right here, okay, that point right there, all right, is when y is 1, right? So when y is 1, 1 plus 1 is 2, x is 2, right? So this would be 2 comma 1. Okay, so we've got all the information to set up our integral now, okay? Now, we're going to start this not at an x value, because we're going to start integrating this way, right? We're going to start them down here, and we're going to go up, right? Instead of going to the right, we're going to go up with these rectangles. So we're going to start integrating at negative 2, and we're going to end it at 1. So that's where, with respect to y, okay, we got to remember that these are y values, okay? All right, so here we go. We're ready to go, okay? The area, okay, would equal the integral, all right, from negative 2 to 1, and those are the y values, so negative 2 to 1, all right, and it's going to be the one on the right, which is 3 minus y squared, so I'm going to put a bracket in here, 3 minus y squared, close the parenthesis, okay, So that, why am I putting that one first? Because that's the one that's on the right. That's the curve that's on the right. So minus, and then this one that's on the left is the y plus 1. Close the bracket. And this isn't dx now, right? Because the thicknesses, if I go this way, my thicknesses are not dx, they're actually dy. So you see how everything's y's, okay? Everything are going to be y values, right? When you have to go sideways, and when you're integrating something that's not a function, okay, you're probably going to have to go sideways, and everything is going to be y's, okay? And even these lower limit and upper limit, those have to be y's. Everything's going to be y's, okay? All right, so here we go. Let's clean this integrand up a little bit. Okay, so this is equal to the integral from -2 to 1, and in brackets or parentheses. I'm going to write the negative y squared first. So negative y squared. This is a negative y. That's the only one, right? So minus y. Here I have 3, but I'm going to take 1 away, right? So that's plus 2. Okay, and then I'm going to close my bracket. You could also use parentheses and dy. Okay, and this one I'm going to do by hand again. Okay, all right, so if we do this by hand, this is equivalent to negative y cubed over 3 minus y squared over 2 plus 2y, and we're going to integrate that, or not integrate, evaluate it from -2 to 1. Okay, so this would be equal to negative of -2 cubed over 3 minus -2 squared. Oh, you guys, I'm messing up. Oh my gosh, why am I doing? You got to do the top one first, right? Holy schmoly. Sorry about this. Holy schmoly. Okay. Ay, 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 ay. All right, putting 1 in. Okay, so negative 1 cubed over 3. You're probably sitting there going, what is he doing? Minus 1 squared over 2 plus 2 times 1. Close the bracket. Minus, okay, now we got to put the -2 in, right? So negative of -2 cubed over 3 minus -2 squared over 2 plus 2 times -2. Okay. So this is negative, I'm going to put this in brackets. So this is -1/3. Let me slide it up a little bit. -1/3 minus 1/2 plus 2. Close the bracket. Minus, I would hold off on trying to distribute, okay? Because you're cubing and stuff negative values, and you don't know necessarily the signs, and it's hard to keep everything track in your head. So, okay, so if we cube -2, that would give me -8, but I'm already taking the negative out, right? So that's 8/3. We had one similar to this earlier, right? And this would be -2 squared, so that'd be 4, so minus 4/2, or 2. If you wanted to write 2, there's nothing wrong with that. And then minus 4. Okay, so this is -1/3 minus 1/2 plus 2 minus 8/3 plus 4/2 plus 4. Okay, -1/3 and -8/3 makes -9/3. -1/2 and 4/2 makes plus 3/2. 2 and 4 makes 6. Okay, and that's -3 plus 6, that'd be 3, right? So again, 3 plus 3/2, right? So we got to get a common denominator of 2, right? So that would be 6/2 plus 3/2, right? And that would give you exactly an area of 9/2. Okay? All right, guys, that's example number 4, okay? And on these 4 examples, everything's been nice values, okay? Everything's been nice values, okay? All right, so you're going to see next, it's not going to be nice values, okay? All right, and this is actually an old AP exam for the next example, okay? Or from an old AP exam. Okay, guys, let's go to the next one and we'll be done. Okay, so let f and g be functions given by f of x is equal to 1/4 sine of pi x, and g of x is equal to 4 to the negative x. Okay, so this one down here is 4 to the negative x, and this top one right here is f of x, the 1/4 plus sine pi x, okay? Let R be the shaded region in the first quadrant enclosed by the y-axis and the graphs of f and g, okay? and let S be the shaded region in the first quadrant enclosed by the graphs of F and G as shown in the figure above, okay? Find the area R, right? Okay, so find the area R. Okay, so what we're gonna need to do is we're gonna need to find these two intersection points, right? Okay, now, if you look at part B, we're gonna have to find the area of S. Really, we wouldn't need this one to do part A, right? But I am gonna need this one for part B, so we might as well find it right now, okay? All right, so we wanna set these equal to each other, right? Okay, so 1/4 plus sine pi x is equal to 4 to the negative x, right? Okay, and so we're going to get two x values. And how do I know we're going to get two x values? Because we have two intersections right there and right there, right? And this is, okay, so both of these are functions, right? Both of these are functions, so we're not going to go sideways, okay, like we did in the last example 4. We're going to want to go vertical because they're both functions, right? F of x is a function and g of x is a function, okay? All right, so we're going to use our calculator to get these two values, and we're going to use our calculator to integrate, okay? Because this is using technology, and hopefully you realize, okay, there's no way you're going to be able to just look at this and go, oh, it's this, it's 2, right? Like you've been able to do, okay? All right, so that's why I showed you with simple ones that you could read and see and make the connection. Like, okay, I could do this by hand. I can also use technology, and the graph confirms it. Okay, so there's a lot of things that are helping you, okay, to understand this. At least that's the point. Okay, all right, let's solve it. All right, so what you want to do is we want to go into y equals, and we're going to type in f of x. Okay, so that would be we want a fraction bar, so 1/4, right? 1/4 plus sine of pi x. Okay, so we know sine just goes, the highest it goes is 1 and the lowest it goes is -1, right? So we see a maximum on that top curve, right, on f of x. And so this is between 1 and -1, and we're adding 1/4 to it, right? So the top, I would put the top at like 1.5 or so, okay? All right, and then and for my y max, that's what I'm saying, okay? And then y2 is 4 to the negative x, so 4 raised to the negative x. Okay, and then let's go to our window. Okay, so this is what I was saying. Let's make, because it says first quadrant, right? So for our first quadrant, x min is 0. The x max, okay, because we're taking 1/4 and the biggest value of sine is 1, so that'd be 1/4 plus 1, right? That's 1 and 1/4, 1.25, right? Let's go a little bit higher. Let's go like 1.5. I'm sorry, for my y's, okay? For our x, I would go like out to 2 or so, okay? Let's go to 2. And x scaled by 1s, okay? Y min, let's go 0 first, because of first quadrant. Y max, that's what I was trying to discuss, okay? This is the one that needs to be like 1.5. And let's just graph and see. We can adjust if we need to. There we go. And we're actually seeing too much, right? We're seeing this out here, and they're not showing that on our graph, right? So I'm going to go to zoom, and I'm going to do zoom box, okay? And I'm going to come over here down and to the left. And I'm going to just zoom in. So press enter. That's my bottom left of my screen's going to be. I'm going to slide over here to the right and come up. And this is going to look more like what our grid looks like, right? What our graph that they gave us on the paper looks like. And press enter. There we go. Okay, now it looks more, right? So we want to find this region right here, right? So we got to find this intersection right here, okay? So second, calc, and then intersect. And then I'm going to come over here and just get close to it. Enter, enter, enter. Okay, so it's not a nice value, right? 0.178. Okay, so we'll record this on our paper in just a minute. Okay, and then we're going to come over to the other one, right? And second, calc. And then let's just come over here to this one and find this one on the right. And you know what? Hold on. I just realized we got to go back to the home screen because I haven't stored it, right? So let's type X, because right now X is stored. As soon as I go over, do the next one, it won't be stored anymore, right? And okay, so see, it already overwrote it. Okay, so we got to go back. I'm sorry. Dang it. Okay, intersect. First curve. Let's get over close to that one over here. It took the X value that was down here when I hit it. Okay, so now when I type X, it'll be the 0.1781. Yeah, see. Okay, so we want to store this as alpha A. Okay, so it's going to override what we earlier stored A as, right? Okay, and then second, calc, and then intersect, and then come over here to this other intersection. And then just press enter, enter, and enter. And it's 1, right? Okay, so you could store this or you could use the number 1 because it's exactly 1, okay? I'm going to store it just because I want to show you how to do that, okay? So quit, and then X, and then we're going to store that as alpha B. It's just as easy to type 1 though, okay? All right, let's go back and record these two values. Okay, so we got, for the first X value, for this one right here, we got 0.178. Okay, 218 and so on, right? Okay, and the other one we got, actually, I could take the approximate off, right? Because it was exactly 1, right? Okay, so we're going to let A be approximately 0, or you could write equal to 0.178,218,0487. That's all the decimal places that were shown to me, okay? And then B is going to be equal to 1, okay? Now, to do our area, right? We are going to, so the area would equal the integral, okay? And it would be from 0 to A, okay? And you've told me what A is, right? Or you could write 0.178, okay? But you wouldn't want to type in 0.178. You'd want to type in all of it, okay? I'm just going to write A, okay? And then we're going to take this curve, right? All right, so this curve right here for the R region, right? Because that's what we're finding. The R is, the top is G of X, right? So this is going to be G of X minus F of X, and then dx, okay? And then that would give you, all right, we can go put it in our calculator. Now remember, G of X is Y2, right? And F of X is Y1, okay? So we're going to go to our calculator and put this in. Okay, so if you press Y equals, just to show you, yeah, this is G of X right here, Y2, right? So second, quit. Okay, so we're going to integrate, right? So alpha, window, number 4 for integration, okay? And we're going to go from 0 to our stored A value, alpha A. Okay, and then Y2, because that's their G of X function, so alpha trace 2 minus alpha trace 1, and then dx, right? And then press enter. Okay, so 0 points, and you know what, if you're dealing anything with trig functions, you need to make sure up here on your calculator screen it says radians, okay? So 0.065, right? 0.065. Let's go ahead and go back and record. So we got 0.065, okay? So the area of R is 0.065, okay? So now we want to do S, right? Okay, and that's part B. So let's do that one. Okay, so we already did the intersection, so we don't need to do that again, okay? So the area for S, or area of S, okay, the area would be equal to the integral, right, from, and it's going to be A, right, the 0.178, okay, to B if you want to use B, or write the number 1. They're interchangeable, so you could use 1 or B, Okay, I'm going to write 1. Okay. Now, what was the top curve? Okay, so the top curve was f of x. Okay, if you look back up at the page, right, it would be f of x minus g of x, and then dx, right? And then we could put this into our calculator and get it, right? And now f of x is our y1 and g of x is our y2. Okay, so we'll go back to our calculator and put that one in. Okay, so from our home screen, we press alpha, window, and number 4 again. Okay, and we're going to go from a to 1, so alpha a to 1, and then y1, right, because that's our f of x, so alpha trace y1 minus alpha trace y2 and dx, right? And 0.410, right? Okay, because the 3 won't cause the 0 to change. So 0.410, and that's the area of region S. Okay, so from the calculator, we got 0.410. So the area of S is 0.04. Whoops, whoa. Too many zeros, right? 0.410. And if you put 0.41, that's fine too, okay? Because that's the same. All right, you guys, that's it. That's the area between curves, okay? Let me get the assignment sheet and we'll go over that one, okay? Okay, so for the assignment, okay, I want you to do worksheet 9-3. Now, this is going to be the most intense work that you do for this unit, okay, by far, okay? But all you need to do is just, okay, so don't do them all by hand. Please don't do them all by hand, okay? You don't need to, all right? You can do you need to be able to do the intersection by hand, and also with technology. So just balance it, okay? Just do some of them by hand. Do the easy ones by hand, and the ones that look a little more complex, use technology to find the intersection and to do the integration, okay? But some of them do by hand. I'm not going to tell you got to do them all by hand or all of them with technology. It's your choice, okay? But do a balance so that you know how to do both, okay? All right. So worksheet 9-3, it's going to take you a little bit of time. There's quite a few problems on there, okay? All right. Usually, I mean, this is always on the AP exam normally. This is the part that was cut out, right? Okay. But they're going to expect you to be able to do this if you pass the AP exam and you move on to the next calculus class, okay? If that's your inclination, okay? All right, so I'm doing all this work right now for you guys, not because we need for the AP exam, just because you need it for the next math class, okay? Honestly, all right? All right, you guys have a great day. Take care. See ya.